Hey students, this is lesson 624, parallel and perpendicular lines. Some of this will be a little bit of review, the parallel part, but the perpendicular part will be new. We're going to learn how to determine whether lines are parallel, perpendicular, or neither. And we're going to learn how to write equations of parallel and perpendicular lines. So let's get started here. Go ahead and just do this. You can pause if you want. See what you remember about reciprocals. Reciprocals are numbers like these, so this is just a quick review, where the number is flipped. And if you multiply those, you always end up with 1. And just for your information, the reciprocal of a number like 5 is 1 over 5, because 5 is really 5 over 1. And so again, when you multiply those, you get 1. Pairs of numbers that are reciprocals, any two numbers that will multiply and give you positive 1 are reciprocals. All right, here, the graph showing it right, you can draw a line that will not intersect either of the lines in the graph. Can you draw a line? If so, drive a line. Why not? The answer is no, you couldn't, and you can try if you want. Like if I drew a line like this, I would definitely be not intersecting that blue line, but if you think about it, this line continues and continues and continues, and so does this line right here. And if I do that, eventually those two lines will cross somewhere. So, and notice how they keep getting closer. So no, you can't. Can you draw a line that will intersect one of the lines in such a way that the intersection forms 4 congruent angles? Yeah, those are called perpendicular lines. But if we just take one of these lines and situate it in the right way, we should be able to get a perpendicular line. One way I can help get that perpendicular line is to use an object that I know has 90-degree angles, like a rectangle or a piece of paper or something like that. And if I put that up along this one of these lines here, say this red line, and I make it perpendicular, then I can use that to help me find a line that would be perpendicular. Now we're going to use some other ideas to help come up with those perpendicular lines. All right. Here's a key concept that's just a review. Slopes of parallel lines. Non-vertical lines are parallel if they have the same slope and different y-intercepts. Vertical lines are parallel if they have different x-intercepts. Now, any two lines that are parallel will have exactly the same slope. So, if I want to have the same slope as this equation, I need 2 as my slope, my coefficient of x. These two lines here will be parallel because they have different y-intercepts and the same slope. And all vertical lines will be parallel. So those two will be parallel. All right, so we're going to use that idea to write an equation of a parallel line. We want an equation of slope-intercept form of the line that passes through the point 215 and is parallel to the graph of y equals 4x minus 1. Well, right away, we're going to take this from that equation. We know that in this new line, we'll have a slope of 4. So we know it's going to look like this. And now all I need is, I need it to go through that point. Now the way we figure out what the y-intercept would be if it goes through that point is we just substitute those values in. So we're looking for this y-intercept deal. We know that x is 2. When x is 2, y is 15. So if I substitute 15 for y, and I substitute 2 for x, and I simplify that, so I get 15 equals 4 times 2 is 8 plus b. Then I just subtract 8 from both sides, and I get 7 equals b. So my y-intercept is 7. So I have everything I need now. My slope is 4. My y-intercept is 7. So my equation of my line parallel is 4x plus 7. Right. Why don't you try that and you can check back with your answers. We're going to do this one a little different. We're going to use point slope form. Now remember, for point slope form, we need an x value and a y value. So in this case, -3 is my x sub 1, and -1 is my y sub 1. And we know that the slope is 2. So we're going to just do y minus -1 is equal to 2 times the quantity x minus -3. And then just simplify that a little bit. And we want to put that in slope-intercept form. We learned how to do that in the last lesson. So that's y plus 1 equals 2 times quantity x plus 3. When I simplify that, to put it in slope-intercept form, we're just going to simplify this equation using the distributive property. We need to multiply 2 times x and 2 times 3. And we get that. And then just subtract 1 from both sides. And we get y is equal to 2x plus 5. Okay, now new concept, slopes of perpendicular lines. Now check this out. Don't read this yet. Let me just demonstrate it. We know that these two are perpendicular because if I took a rectangle and I put it up to that angle there, we can see that that line is a 90-degree angle. Right there. Okay, and we know that because rectangles, all the angles in rectangles are 90-degree angles. All right, so that's a 90-degree angle. Now, check this out with the slopes. If I put a point here and a point here, and I do rise over run, that's 4 over 2. So that slope of that red line is 4 over 2, which is 2. Okay, now if I do the blue line, I'm going to just put a point right here. And rise over run. This run is 4, and the rise is actually -2 because it's going down there. So that's -2 over 4. Well, notice right away that this slope is 4 over 2, and this is 2 over 4. Only one is positive and one is negative. And 2 and 1/2 are reciprocals. When you have perpendicular lines, they are opposite reciprocals. And when you have opposite reciprocals, if two numbers are reciprocals, their product is +1. When you have opposite reciprocals, their product is -1. And I'll just prove it to you one more time by making another graph and just drawing a couple lines that I think are perpendicular, and then we'll check their slopes. So here I have a point. I'm just going to draw it here. And I'm just going to make this one, actually, we'll put a few points in here. And this slope is -2/3. All right, so that slope is -2/3. Let's draw another line here where my slope is, let's flip those over, and that's 3 over 2, but we'll leave this positive so that if I multiply these two right now, I would get -6 over 6, which is -1. And if I do another line that has a slope of 3/2, and I'll just start like right here, so I'm going to put a line there. Let's get rid of that line. So it doesn't affect, so I'm going up 3 over 2, like that. All right, and if I draw a line through that, and then draw my other line back through those other points, like that. Now, if you look closely, you should believe that that's a right angle, but just to check it, make sure, I'm going to do my rectangle test again. Put that in there. And turn it so that it fits that angle just right. And we can see that those two lines form a 90-degree angle. So the idea here is that if you have two lines that have slopes that are opposite reciprocals, that those two lines will be perpendicular. So the slope of this blue line, or this red line, is 2. The slope of the line that's perpendicular to that will be the opposite reciprocal. 2 is the same as 2 over 1. Flip that over and put a negative in front of it. And now when we multiply those two, we get a product of -1. And when that happens with the slopes, those two lines will be perpendicular. All right, so let's go ahead and use that to do a couple problems here. Are the graphs of 2y equals -3x plus 6 and y equals 2/3 x plus 2 parallel, perpendicular, or neither? So this one has a slope of 2/3, and we know that because that's written in slope-intercept form, y equals mx plus b. This one is not written in that form, so we're going to just change it quick. And we can easily see the slope if we divide both sides by 2 and put it in the slope-intercept form. So that gives us y equals -3 divided by 2. I'm just going to leave that like a fraction. 6 divided by 2 is 3. Now we can see the slope is -3 over 2. And -3 over 2, how does that compare to this? They are flipped, and one is positive and one is negative. If we multiply those two, we're going to get -1. So we're going to say that these two are perpendicular because our slopes are opposite. These two numbers are opposite reciprocals. Okay, so let's try another problem there. Go ahead and you can try it, and you can check back with the answer. Okay, when I put it into slope-intercept form, I found that the coefficient in slope-intercept form is 4/3, and 3/4 and 4/3 are reciprocals, but they're not opposite reciprocals, so we're going to say that the lines are neither. To be parallel, they'd have to be the same. To be perpendicular, they'd have to be opposite reciprocals. And just to quickly prove to you that they don't, if we have a line with slope 3/4 and a line with slope 4/3, so let me just insert a graph here real quick. So if we put on here one line that has a slope of 3/4, that would be points like this, down, up 3 for every 4 I go over. So those are 3/4. And then if I go ahead and draw a line through those, and now if I have another line that has a slope of 4/3, that means I'm going up 4 for every 3 I go over. So I'm going to use this point there, and then go like this. So all of these points are up 4 over 3. If I draw a line through those lines are not anywhere near perpendicular. Okay, so let's go ahead and do this next problem. The graph of which equation passes through the point 10, the graph of which equation passes through the point 10, 15, and is perpendicular to the graph of y equals -5, 6x minus 2. So there's our big clue right there, -5, 6. That's the slope of the line. And we could graph that if we wanted to, put a -2 here for our y-intercept. A slope of -5, 6 means I'm going down 5 for every 6 I go over. That would put me like there. So I drew a line through something like that. All right, now which of these could be perpendicular to that? Well, if they have the same slope, they're parallel. So we can cross out these two that have the same slope. And so it's either C or D, and we just have to figure out which one goes through the point 10, 15. To do that, all we have to do really is solve, substitute 10 and 15 in for y for both of these problems. I'll do it for D here. So y would be 15 and x would be 10. So I'm just checking to see if that works. 15 is equal to, and if I do 6/5 times 10, 6/5 is the same as 1.2 times 10 is 12 minus 5, and that's equal to 7, and that's definitely not true, so I'm going to cross out D, so it must be this one, and just to check that quickly, y equals, so y is 15, x is 10, and again 6/5 times 10, that's 6/5 is 1.2 times 10 is 12 plus 3, that is true, so my answer is C. All right. My video is getting a little long here, so I think I'm going to pause here and then start a new video for part 2.